morning, we are going to go a step further and see how it was applied to the Pokuase Interchange project. But then to recap, last week, I did start by defining what value is. And engineering, we said that value generally means the importance or worth or even usefulness of something. And engineering, as we also know, is the science and art of applying scientific and mathematical principles, experience, judgment, and common sense. And I think that I wanted to talk about the issue of common sense in engineering. Therefore, it is not all about science, it is not all about technology, but it also has to do with even art. And therefore, when we are evaluating our projects, we should not be myopic in our views. Then I went on to explain what value engineering meant, or to define what value engineering is. And I did mention that value engineering, as you can see on your screen, had to do with an organized effort, which is directed at analyzing, projects, systems, materials, but with the main aim of achieving a certain essential function at the lowest life cycle cost. So here we are talking about value, and I explained that the goal of value engineering is value improvement. It is not just about reduction in cost, as sometimes we want to believe. And the value improvements might relate to scope definition, functional design, constructability, coordination, and all sorts of things. It also means that you would want to minimize unnecessary costs, because there are certain costs which are uncalled for. You want to optimize processes. You want to increase, profit. So all those things are good, but then that should not be the sole aim. At the end of the day, the value is important, and I defined value mathematically as being directly proportional to function and indirectly proportional to cost. So it is value is equal to function over cost. And you are engineers, so you would appreciate the fact that if the function increases and the cost remains the same, the value would increase. In the same vein, if the function stays the same and the cost reduces, the value would increase. Now, we looked at this particular graph and said that, yes, you can have low cost, low value, high cost, high value. But what our target is always is low cost and high value. That is always our target. We want to reduce the cost, but at the high. And the question that one may ask is that, what is the reference cost? So you see, it is therefore an iterative process. You start with something and then you would want to refine. You don't tell yourself that this is the solution, because as engineers, we provide solutions. That is our main job, to provide solutions, not a solution. There are many solutions, but then you need to take it through the iterative process of coming up with the best solution. And the best solution may not solve all the problems, but then it has value. And that is what we are talking about. So it is about optimizing the elements of the project through an analysis of all the factors. Cost, by all means, has to be there. The upkeep, maintenance, aesthetic, and everything is all part of it. And then we went on to look at the approach. And I mentioned that there is no standard approach. All you need to do is to discuss with team members, and you have to ask questions. Engineers, you have to be more like skeptics. Don't just see one solution and tell yourself that I have arrived. Ask questions. Ask yourself, what functions are being performed? What is the material specification? What quantity of material should be used? Are there alternatives that have to be used? Are there possibility of elimination? Just begin to question. And I used my own case, that a maxim that I have, that because things have always remained the same, is not enough reason we must not change. Change is always necessary, and we must be adaptable to change. Don't be set in your ways. Don't be set in your mind that there's no other. Even something that you have done over and over again. Somebody asked me about value, the difference between value engineering and value, what was it? Value analysis or something. And I did mention that the difference in the two is that one may be an established process. One is an established process, but then you can also have a situation where you have a new, and what we are talking about, when you have a new product or a new design or a new construction that you're undertaking, that is where you do the value engineer approach. For the value analysis, it's something that is existing and you'd want to find ways of improving the value or increasing the value. Then we went on to look at the methodology, and please let us take note of it. We start with information gathering. You have to do a functional analysis. You brainstorm, and the whole idea of brainstorming is to come up with alternatives. And having done or come up with alternatives, which is something that we do. When we are doing economic analysis, you have to come up with alternatives. And then you evaluate these alternatives. And having done that, you then move on to that particular alternative and develop it further. And then you make a presentation to your client. So what are some of the benefits? Cost savings, improved efficiency, and a better quality of the product that you are providing, and enhanced safety and the reduced environmental impact. So basically, we also look at this particular graph, which says that the question that comes is that when do you undertake value engineering? Should it be at the planning stage? Should it be at the operation? And the answer was that it can be at any stage. However, if you look at those two, there is a resistance line. In the beginning, the resistance is low. But as you begin to get into the time of construction and maintenance, then there's a high resistance because people do not want to change something that has already been designed. But then we should always be on our guard that it is possible. Then we also have the acceptance line. When you start, the acceptance is very high. As you get into those areas, the acceptance goes down. And therefore, in the beginning, if you are able to have a good value engineering exercise, you stand a lot to gain, as opposed to waiting till the end. When you have bought everything, then you want to change the method of construction. That would create a problem. So having done that, we are now moving on to the case study. We are looking at the case study of the Pokuase Interchange and local roads project. And please permit me in the first few slides to talk about some background information. This is the Ministry of Roads and Highways was the implementing agency. The Department of Urban Roads was, well, it is the implementing ministry, and then the implementing agency was the Department of Urban Roads. This project was financed by the African Development Bank and the government of Ghana and associated consultants. And this, I'm talking about the initial stage, that is the design, the design and supervision of this project. So associated consultants did the design entirely on its own, and the construction, we partnered with Begin Group of South Africa. And the contractor was Zome Engineering Group, and they did quite well. So our scope of works, we have to do design review, supervision and contract administration, safeguards, compliance monitoring, documentation and reporting, and then the post-construction. So please permit me at this stage to introduce Associated Consultants to you. Associated Consultants is the leading infrastructure consulting firm in Ghana. We are a multidisciplinary firm, we maintain world-class technical expertise. We are a wholly Ghanaian-owned firm, founded in 1968, and we maintain high standards for quality, health, and safety. And we are committed to delivering projects on budget and on schedule to the complete satisfaction of our clients. And I believe that at this stage, Associated Consultants is the only consulting firm, local consulting firm that is ISO certified, 2015 certified. Our core operations are in water supply, project management, quantity surveying, transportation engineering, social impact assessment, bridge structural engineering, architecture, environmental impact assessment. And we have, as I mentioned, very young, and there's a very fine blend. They're very old, they're not too old, and the young ones, they are all blending. This is just a snapshot of those that we have, within. So now let us move on to the design and construction of the Pokuase Interchange. So to start, I always have this quote, just like what you would say in the beginning, God created the heavens and just ruled The intersection was chaotic with several accidents coupled with high pedestrian and vehicular traffic. Who fought for space? Who fought for space? The pedestrians on many occasions lost the fight. So the government of Ghana looked at this and was unhappy. Therefore, approached FDB for funding of an interchange and approach roads. So let us first look at design. And at this stage, you see where we applied the value engineering process. Our design phases, conceptual, draft, and the final. But before then, we do not just say that we are going to put up a 3-tier or a 4-tier interchange. It has to be data-driven. It has to be driven by traffic modeling and information. We have to check other factors. So we came out with 7 alternatives, and this is where the value engineering is. 7 alternatives were considered, and each option was then subjected to factors. Remember what I mentioned, that you then go through the process of looking at the various options and then alternatives, and then subjecting them to a rigorous analysis. This is what it is all about. We've done the functional analysis. We have now come to the point where we are looking at the alternatives. And in our case, the factors that we use were, what is going to be the land take in terms of overall property impact? Are we going to impact so much property that we cannot even pay for? What is the capacity that we are going to derive of, or then when I talk about capacity, we mean the traffic capacity. And then the cost. Is it going to be so expensive that we cannot build? And as I mentioned, value engineering always must have a cost element in it. Then complexity. Is it going to be so complex that nobody else can build, apart from maybe people from the US or from the UK? No. Our plan was to ensure that it wasn't too complex and it can easily be built, by Ghanaians or any international contractor. So the schemes that we explored, the first one was an upgrade signalized intersection. And I'm not going to go too much into the detail. So we said, okay, hey, why don't we just have signalized intersection? So from Awoshi to Kwabena, and then from Nsawam to Accra, let us just have an intersection there, traffic upgrade. So we looked at that. Then the next one was look at a 3-tier rotary interchange, like the one you have at Akwaje. Let us explore that. So that is what we had. Okay, what about going to a partial cloverleaf interchange? Partial, not the full cloverleaf. So a partial cloverleaf like what you have at Apenta. Then the next one was, okay, full cloverleaf. This, at Tetekwashi, we have a full cloverleaf there. Then let us go into more like a system interchange. So we are looking at a 3-tier directional interchange. Directional, we don't stop or move anywhere. Then what about a semi-directional interchange? And these were all, you can see that we have drawings. We just didn't think of them in our mind. We have to draw or sketch them, okay, to validate our concepts. So these are all parts of the value engineering process. So then went into a 3-tier single point urban interchange, what we normally refer to as SPUI. SPUI, 3-tier single point urban interchange. So having done the evaluation, now I'm going to the next stage. You remember the approach, you have to do the evaluation. Having done the evaluation, we came up with a selected scheme. At the end, even after you have selected a scheme, you still have to drill down and ask yourself, what are the positives and what are the negatives? What could happen? What could go wrong? And remember, I did mention that there's something we call fatal flaw analysis. Because in fatal flaw analysis, what you are doing is that you want to identify, discuss, and mitigate the risk for your projects. Every project has risk, but you need to know them. If you don't know them, how would you mitigate? There are issues of technology risk. You can design something nobody else can build because it becomes building a castle in the air. So you have to ask yourself, can this be built? And remember, I talked about constructability. Engineers don't design something that nobody else can build. We can only build it in the computer model. But then on the ground, like the account will say, agronomic form. So if you cannot build it, please think about. In other jurisdictions, what they do is that the designs are even given to contractors. And then the contractors, we ask them, can you build this? How are you going to do this? So the contractor will come up with a methodology for the construction. Sometimes you don't even have the materials in country to import. How much is going to cost? These are things that one has to look at. Then the risk of what you are providing. You are providing something that may be risky. And many other environmental. You know, in our case, we had the Gua Co. Co in Ga means forest. So Gua Forest was very, very close by. And if we're going to impact on it, what will be the level of impact? There were a lot of properties there. How were we going to impact on the properties? We had to pay for them. So all these things were looked at. What about the resource? Do you have the money to construct? Yes, we can do 10 tier. You can do whatever you want. But do you have the money for it? Is it necessary? Remember, I talked about unnecessary costs. We want function. We want to reduce costs so that we can have value. That is the most important. And then many other things that we would I mentioned. So here we look at the positive attributes for our selected scheme. Number one, there were no conflicts between opposing left-hand movements. And you know that in traffic engineering, our challenge has always been with the left turns, because when you are turning left, those that you are crossing will have to stop. And if you want to take out the left turns, you reduce conflicts in terms of crashes, possible crashes, whether it is side, swiping or front rear collision, and all that. Those are possible. So we have to look at that, and that is taken up. Right turns are free flowing and a relatively smaller footprint. Just consider or combine. Look at what I gave you. For instance, the full cloverleaf option. The full cloverleaf may be good, but then the land take is huge. So you can compare what we have there and then what we have at Tetekwashi, you know. Then the fatal flaw. So we ask ourselves, as I had explained to you, we have to discuss, we have to identify and discuss and mitigate the risk for our project. So we realize that, hey, you could have high costs due to the length of the bridges. If you have, because the whole costs or the cost center of interchanges is the bridges. The bridges cost. So the major cost centers are to do with the bridges. So what then do we say? Okay, let us reduce the length of the bridges so that we'll have a lot more embankments, so that you reduce the cost. Also, earth is not too expensive in Ghana, so we have to look at that. Maybe in other jurisdictions where they do not have the material, that may not have been their solution to the high cost. They may have looked at other options. Then we said it is vulnerable to the signal failure, because in the middle tier, we were going to have only left turns, only just what we call a two-phase signal. Stop, go, not that complex four-way or four-phase or three-phase signals. So this was going to be a two-phase signal. Then we said it is vulnerable. What about if the power goes off? So we said, okay, then we'll use a solar-powered signal. Then provision for pedestrians are complex. In a situation like this, where would the pedestrians cross? They cannot use the interchange. So we said then we have to provide footbridges and underpasses where feasible. So these were how we undertook out. And again, this is for the purpose of presentation. I'm only showing a small number of things, but then that is what we did. So this is what we came up with, as you can see on the left. So this was the original SPUI. That is a 3-tier single point urban interchange. That is what you have there. I think that this is going to be a similar construction for the motorway interchange when it is completed. When the phase 2 is completed, this is how I believe it's going to look like. I can be corrected if I'm wrong. Yeah, so this is square. So this is what we went to town with, and we asked the contractors to bid. So tier 1, that's the very lowest level, is the south-north movement. That is a tier 1 is the Accra Kumasi Road. Then we had tier 2, which was a signalized intersection for the interchanges, so that if you were coming from Awoshi going to Kumasi, or from Accra going to Awoshi, or from Kwabena going to Accra, or that kind of arrangement. That is where you were going to turn. And then we also had the free flow right turn, which was not subject to any traffic. And then tier 3 was the Awoshi Kwabena Road, that is at the very top level. And then we also had a bridge over the railway, which is to the western end of the interchange, and a very long bus stop to facilitate the operations of the bus rapid transit, which was piloted some years ago. So these were basically the features of the 3-tier single point urban interchange that we designed and went to town with. And very soon you'll get to know how value engineering led to the 4-tier interchange. And this is even at the design stage. So as you went on to the next level, you see that you can have value engineering at any stage. Even after doing all this, we had to do another one, and I will explain why we did that. As I mentioned, we had footbridges and underpasses, but I'm not going to go too much in that. So now I'm looking at the selected scheme, and then we had some, again, I'm going too much probably, but just for the benefits, because we have various types of engineers here. Because even when it came to the bridges, the type of bridges to choose, is it going to be post-tensioned? Is it going to be precast, post-tensioned, or pre-tensioned, precast, cast in situ? All sorts of combinations. Is it going to be steel? What are you going to do? So these are all part of the processes of you have to undertake a value engineering process, even for the choice of the technology or the choice of material. So we came up with post-tension, pre-stress concrete, triple cell box girder, and I'll be showing that to you very soon. We had reinforced concrete box girders provided for spans up to 21 meters. So it's not everything that was post-tension, where we had shorter spans up to 21 meters. We just did the normal RC, that is reinforced concrete box girder, without any post-tension. Then there are others too, where we had box girders for spans, that's the post-tension or post-tension pre-stress concrete for spans up to 48 meters, between 38 and 48 meters. And then there are areas where we have separate box girders and all that. So these were things that were chosen, and all at the time of design, because for bridge design, you should know how you are going to construct it, even before you do the design, because the manner of construction has an impact on your design procedure or design process. Very important. I'm not a bridge engineer, but this is something that I have learned having been on the project for all this while. Yeah. So again, what are the advantages? Like we always do, you must have advantages and disadvantages. Whatever you do, don't just do it by rote. There must be a reason for doing it. And this is what we came up with. We said that it was suited for use in curved bridge systems because of the high torsional rigidity. It is aesthetically pleasing, and they use a combination of primary high tensile steel and reinforcement. And this is something that we already know. And some of the bridge sections. So this is just showing the plan of the various bridges. We have the top tier, the ramps, and then the middle tier, and then retaining walls. So in terms of the sections, we have the longitudinal section, just showing you the spans. So you can see ranging from 38 through 48 all the way. And again, these were all at the design stage. We'll see that once we got into the construction stage, we had to make some changes using value engineering. And that was a value engineering from the contractors. And so the railway bridge, as I mentioned, and the spans are also very clearly shown here. So for instance, this is a single box post-tensioned cross-section. Then we also did another interesting thing. For the middle tier, we used a voided slab. I think that there's one voided slab on the N1. That is the one that was done by GHS some time ago. Yes, that's another cross-section showing here. So now let us move into construction. So now we have gone to town, we've gotten a contractor, the contractor is on site, we have to undertake a design review. And it is always good for those of you who are contractors that you subject these designs to your own checks and value engineering. It helps because at the end of the day, when you are able to come out with a good proposal, you earn half of the savings. Yes, the half of the savings will be for the contractor. So there's good reason why you must undergo or undertake value engineering. So there's some money to be gained. So in 2018, the contractor came to site. These are just the contractual details which I've already shared with you. The project was awarded in March 2018, and we'll get to know how. So the construction works. So basically what we're doing is that we're going to construct an interchange at Pokuase. We're doing 7 kilometers of storm drains, and this is something that a lot of people do not know. We're also doing, or we did, now at the time we say we're doing, we did 15 kilometers of local roads. We also did 7 kilometers of the Awoshi Pokuase to Kwabena Road. Then we widened 2 kilometers of the Accra Kumasi Road, which we are all privy to, or those of you who have used the road know. Then we provided pedestrian facilities, including walkways, footbridges, and signalized cross sections, street lights, and free health screening for projects, persons in the country. Now, another very important thing that we do, and for those of you who are supervisors, when you are supervising a bridge project, when the contractor comes to site, or even at the time of putting together your bills of quantities, you have to ensure that you have a certain amount of money for geotechnical investigations at the peer locations. Because as consultants, we cannot do geotechnical investigation for all peer locations. We only do sampling. But with the benefit of Pokuase Interchange, I can tell you on authority that even 1 meter from one point, the soil could be very different. And this is what we found. So when the contractor came to site, and this has already been put in, we asked that every peer location or abatement location, there was a need for us to conduct geotechnical investigations to confirm what had earlier on been used for the design. Soil profile, soil characteristics, rock characteristics, these must be looked for. Because if you do not, you could have failure. And please, in my research some years back, even in the US, there were failures of bridges when this was not done, because they thought that what had already been probed in the beginning was okay. But then during construction, they realized that the materials were very different. You may blame the geotechnical engineer for not doing a good job, but I'll tell you this is not the case. So as we said, after the confirmatory tests were done, the recommendation was that instead of providing a few piles at the pier locations as had been envisaged at the time of design, there was a need for us to provide piles for all engineering team to support us. So this is just some of the samples from the drilling that we did. And if you look at the quite interesting, it was quite an interesting site to behold, with fault lines interspersed all over the place. So we had to take a decision, and the decision meant that the piles, the rock was competent. We were going to provide what we call the short RC piles. And what I mean by short piles, it means that we're just using, there is some places we were getting 6 meters and all that. Yeah, we could have excavated, but then that would have been a very huge excavation just to be able to put in your foundation. So we did this, the total length of reinforcement, it to be 12 meters. So there are deep foundation design were going to depend on the skin friction. The end, bearing was taken as design, and that we were talking about 28-meter, piles. So then, as I mentioned, and I keep mentioning, value engineering came on board. And last week, I explained to you that in clause 13.2 of the conditions of contracts, all the conditions of contracts, whether red, pink, yellow, silver, all of them, they come up with the same thing. So the contractor came to us and said, look, looking at the methodology for construction and the cost for the bridge construction, then here we are talking about the 3-tier, and then the time constraints, and then the traffic management requirements. Remember that if you wanted to construct such bridges, you need to support them. And to support would mean that the road, that is Accra Kumasi Road, was going to be closed. So they looked at all of this. They said, look, we can provide value to the client. We can provide extra value to the client. And that extra value will mean that we were going to go under clause 13.2 of the conditions of contract, which deals with value engineering, and it permits the contractor to propose a change which will benefit the employer. Design shall not, and this one, you see, it uses shall, it is mandatory, shall not lead to an increase in cost above the original value. It shall not cause a delay in the performance of the contract, and shall be technically superior or equal to the original design, and shall be beneficial to the employer. In our case, our original design had a certain cost, but then in view of the foundation conditions that we met, it meant that we were going to have a very high increase in cost, and we had done the calculations, and we knew how much it was going to cost. So that was going to be our benchmark for our value engineering. So then the contractor came up with this idea of a 4-tier stack interchange, where the middle tier, which we had, it was basically similar to what we had, but then it was going to split, and at the end of the day, this is what we came up with. So from this point, I'm just going to show you a few pictures of the completed, and also show you something about the construction. So these are all things that we had. This is not the actual, this is the computer-generated modeling that was done, and showing all the nice things which we try to do there. And you can see at night what we sought to do. So this is the Pokuase Interchange, 4-tier stack interchange. And to show you the new bridge, that is the 4-tier interchange. Remember the first 3-tier, I showed you what we have done. So you can see that for the top tier, for instance, we employed what we call the balanced cantilever approach. Balanced cantilever approach for the middle tier, because, sorry, not the top tier. And this was the bridge that went over the Accra Kumasi Road. We wanted to construct without putting in props all the way to the road, which was going to block the road temporarily. And that is not what so this was an additional value to even to the construction process, having this particular type of construction in Ghana. Then the box girders, just similar to what we had designed previously. But you can see that these are all on piles. Then we also had another innovation, the retaining walls. Instead of using concrete or reinforced concrete cantilever retaining walls, we went in for reinforced soil walls. And this we used geograde. So the concrete facing that you see is not contributing to the structural stability of the structure of the wall. It is basically a facing. So this is what we did. The main thing is what we call the wraparound. And at the end of the day, these are all part of the designs. So you can see on your left-hand side, you can see that there's a facing, concrete facing, then the wraparound, is another good news is that you can use it, good fill material. You don't need very high quality fill material. So this is what we did for the Pokuase Interchange. The walls you see are not cantilever retaining walls as you would have. And with this one, we were able to construct as high as I think 12 meters. I think our highest was about 12 meters. You remember we talked about instead of having very long lengths of bridges, we would have this kind of retaining wall and embankment. So this is what we did. So I'll just show you some of the construction pictures to show you the progress of construction. So starting with the pile drilling. After pile drilling, we install reinforcement cage, and having installed a reinforcement cage, you use your tremere to deliver the concrete to the bottom of the drilled pile. And having finished, you strip off the pile heads. After stripping off the pile heads, you undertake the integrity test to ensure that's what we call the pile integrity test, to ensure that there are no honeycombs or some deleterious materials within your pile body. And in situations where we had that, we had to repair them. And the bottom picture, you can see some of the repair works that we did over there. Luckily for us, this one was not too deep, so we were able to repair them easily. At the end of the day, you fix your reinforcement for your pile caps, which is going to be the main structure that will receive the loading from the pier and transmit through the piles into the ground, or for your deep foundation. So on your right top, you can see the completed reinforcement cage for the pile cap. Some will go as high as 2 meters or 2.1 meters. And then the pile cap is completed. Your piers are done. The starter bars for your piers are also done. And then you are ready to move on for the construction of your piers. So the process, fixed reinforcement, the formwork, and then the completed pier, ready to receive the our deck. That's a roof deck. And also we use pot bearings. Pot bearings, you can't have concrete on concrete. So we have some pot bearings, and these are all designed, in terms of rotation, whether it is for rotation, whether it is for translation, whether it is for rotation and all those things. So this is all that was done. Then we had earthquake restraints, because we know that we are in an earthquake-prone area, and therefore Southern Ghana is in an earthquake zone. So we provided earthquake restraints so that when there's an earthquake, you don't have the deck moving independently of the pier, which would happen. But then this will restrain the deck from falling. If you look at the Kobe earthquake in Japan, that's what happened. And we have learned from that. So this is just showing one of the box and the reinforcing tendons. If you look, those silverish tubes or ducts, that is where we pass our ducts. That's where we pass our tendons. And having done all that, finished with the top, we concrete. After concreting, when the concrete has achieved 90% of the strength for post-tensioning, then we undertake tensioning. And you can see on the bottom right, the jack, that small hydraulic jack. That is what is used to tension. You pull, you have a dead end, which is anchored, and then this end is free. We just pull it, it compresses the concrete, and then that is all they call post-tensioning. So we tension, cut it off, put in the grouts, and we are ready to go. So that is the thing. Then that is our completed structure. This is one of the ramps. I believe this is the second tier. And then I talked about the balanced cantilever construction, because this is what we use for bridge spans ranging from 50 to 250 meters without any support. During the construction, there's no vertical support or prop. You do it in sections. So in our case, we have segments of about 3 meters. So you construct 3 meters. And the reason it is balanced is that you balance the weight. You do right and you do left at the same time, so that there's a balance. And then you post tension. Then you move on to the next level. You continue doing this until the two sections meet. So on your bottom right, you can see that the completed session is done. And the last session, I remember it was pump and pageantry, at midnight. The Minister for Roads and Highways was there when we did the last bit, connecting from the right to the left. And you can see, ingenuity in engineering. We were working independently, but because we were controlling the lines and levels, we were able to meet at the same point without any deviation. Because if you don't do it well, you can have even a 1 meter deviation of one end and the other, so the two will not meet in the middle. And I showed you the mechanically stabilized earth retaining wall. So basically what we are doing is that we are using geograde to stabilize the earth. And this is what, on the top left, this is a completed session of the wraparound. The bottom is showing how we start. You wrap around and then you put another layer. So we do it in layers of 600 millimeters all the way to the top. And having finished, put in the precast concrete facing. And as I mentioned, these concrete facings do not contribute to the structural integrity or strength of the retaining wall. The main one is the one that we have on the left-hand side. And interestingly, I remember I woke up one day and said, why can't we have, these Adinkra signs and Ga signs? So a lot of the Gans did not know that they also have what they call Sangmai, that is symbols, Ga symbols. So you have some of those symbols, in there. We know the Jinyame, Obi Nka Obi, the next one under the Jinyame. The one is, the next one has to sign for excellence and all that. So, very interesting names. Alaka Nyumo, the uncheatable God, Nani Titishbushi Yaka, sounds for capital and strength, Kayayo, the dignity of hard work, and all the things that we know in SAR stands for excellence. So, and I would want to credit architect Ralph Sutherland, whom I contacted to help me in the arrangement of these signs. Now, another thing that we did was the modular block retaining wall. And here we are using precast blocks for retaining walls. And when you go to the Pokuase area, you can see this. And this also had, it's also a type of mechanically stabilized earth retaining wall because it has it has geograde, to help in the reinforcement of the earth behind the walls. So because we have only 5 minutes to go, I'll just show you the signs of the completed projects, and don't need to talk too much. The picture is well housing top. So I'll just finish with this. And remember, we saw the design, and after building, this is how it looked like. Pokuase Interchange is now completed. And of course, there were challenges like any project. I'm not going to dwell on the challenges now, but then we know about COVID, we know about pedestrians, traffic management, pilfering, people were stealing crash barriers, compensation issues, accidents, and if you go there today, they've hit a lot of, and I think that we need to have, a discussion around some of these things, much later. So the president cuts the ribbon, as we'll say, for the completion of the project. So in conclusion, value engineering, we say, is a method that your project team employs to improve the value of your project by examining the functions of each item or element and its associated cost. And I did say that value is equal to function over cost. It is important to know that improving the value of your project does not mean cutting costs. It also means that optimizing the elements of the project through an analysis of all factors, including cost. There is no standard for undertaking a value engineering process. Discuss with your team. Value engineering starts with planning through design to construction. It's never too early or too late to start. Follow through with the systems in arriving at recommended. So in summary, value engineering is a valuable tool in the construction industry that can help identify cost-saving opportunities while maintaining or improving the quality and functionality of a project. And with this, I wish to thank you very much for this project. And I would like to make some acknowledgements. The Minister for Roads and Highways, the Chief Director of the Ministry of Highways at the time, he was the Director of Urban Roads, and the current Director, Amu, who was a Deputy Director at the time. Then we had the project coordinating unit, led by my friend Richard. Yeah, Richard did very well. And of course, you, the CEO of Ghana Highway Authority, the FDB, the ACOM project staff, contractors, Zome Engineering, and some other subcontractors, and then the traveling public. Thank you so much.
Thank you very much, Engineer Bempong, CEO, as a consultant